Good morning, student. Welcome to the second part of the video. In the first part, we have already discussed about the vector addition, vector subtraction, also about the unit vector, etc. All. In this part, we are going to discuss about the vector product. Vector product can be of two types. One is the scalar product and one is the vector product. It is because sometimes whenever we find many physical quantity which is the product of two vector quantity, but the resultant is a scalar quantity. And sometimes we have found, we have experienced some kind of quantity which is a vector quantity, but their resultant is also a vector quantity. For example, if we consider the work done consists of force and displacement. Force into displacement gives us the work done, but work done is a scalar quantity. On the other hand, force and displacement are vector quantity. But if we consider the quantity called torque is the force in rotational motion. So basically torque consists of two quantity. One is force and another is the position vector of the point of force from the origin, which is a vector quantity. So you can see here torque is a vector quantity. On the other hand, force and the radius vector or the position vector is also a vector quantity. So therefore we have to consider two types of product in vector algebra. One is dot product and another is the cross product. In the dot product, the resultant of the product of two vector is a scalar quantity, and in vector product, the resultant of the cross product, the resultant of the multiplication of the two vector will be a vector quantity. Therefore, we always have to consider two types of product in vector algebra. Okay, so first let me start with the scalar product or the dot product. Suppose A and B are two vector and the angle between the two vector is theta, then the dot product between two vector is represented by A dot B is equal to magnitude of A into magnitude of B into cosine of the angle between A and B. Okay, so A dot B is nothing but AB cos theta. You can see A is a vector, B is a vector, but their resultant is a scalar quantity. Okay, so some special cases also possible. A dot B is equal to B dot A. This is because cos theta is equal to cos of minus theta. So it doesn't matter which vector you considered first or which direction the angle you considered. A dot B will be always equal to B dot A. Okay, so this is first and the important condition. And the second condition is that if A dot B is equal to 0, then either A is equal to 0 or B is equal to 0, or we can say that cos theta is equal to 0. That means theta is equal to 90 degree. So the dot product between two perpendicular vector is always equal to 0. Okay, so this is the third important condition we can derive from the dot product between two vector. And also we can note that A dot A is equal to A square. So if this definition is very important if we want to know the magnitude of a vector. What you have to do, you have to just dot product this vector with itself and you have to take the square root of the product, then you will get the magnitude of the vector. So in order to calculate the magnitude of the vector, this definition of vector product A dot A is frequently used. So you have to keep that in mind. Okay. Okay. So next we are going to consider the cross product or the vector product. As I have already told you, for quantities like torque, which is the multiplication between two vector quantity, this type of product is very essential, which is known as the cross product. And the cross product is defined as A, B sin theta is the magnitude of this cross product, and their direction is in a direction perpendicular to the plane containing A and B. Suppose A is a vector here and B is a vector here. So if we consider this A and B vector in the xy plane, then the resultant will be in a direction perpendicular to both the plane containing A and B. So if AB vector are in the xy plane, then their resultant will be in which direction? It is basically in the z direction. Okay, and their magnitude is AB into sine of the angle between these two vectors, AB sine theta. You see, A and B, they are having an angle theta in between them, and therefore their magnitude will be modulus of A into modulus of B into sine theta, and their direction is perpendicular to the plane containing A and B. Okay, so this direction we can also find from the right hand thumb rule. For example, if A is a vector here and B is a vector here, so what you have to do, you have to curl your hand from A to B, then this thumb will represent the direction of the vector. The thumb here, this direction will represent the direction of the vector. Okay, in the video you have seen the direction of the thumb in the opposite direction. Basically it is in the Z plus direction, so it is coming out of the plane of paper. Okay, and if we consider the vector product B cross A, then what will happen, the thumb will into the plane of paper. So A cross B, the thumb will be outside of the plane of paper, and for B cross A, the thumb will be inside of the plane of paper. Therefore we can say that B cross A is equal to minus A cross B. Here the minus sign represent that the direction is opposite to each other. B cross A, if we consider A cross B, then A cross B direction is plus Z direction, because thumb is coming outside of the plane of paper, and if we consider B cross A, the thumb is going into the plane of paper. Okay, so their magnitude will be same, but what will happen, their direction will be different. So I have written like B cross A is equal to minus A cross B. So this property of vector multiplication is known as the anti-commutative. Okay, so the dot product was commutative because A dot B is equal to B dot A, but if we see the cross product, then B cross A is equal to minus A cross B. So this property is known as the anti-commutation property of vector algebra. Okay, so next important condition is that if A cross B is equal to 0, then what it means, either A is equal to 0 or B is equal to 0, or since the magnitude is AB sine theta, therefore if theta is equal to 0, then A cross B is also equal to 0. When theta is equal to 0, that means what, the angle between A and B is 0. That means A and B vectors are parallel. Okay, so the cross product between two vectors when they are parallel to each other is equal to 0. Remember the thing that in case of vector dot product, when two vectors become perpendicular to each other, then their dot product is 0. But here when the two vectors are parallel to each other, their cross product is equal to 0. Okay. There is a special rule of the finding out the cross product between two vector. It can be done using the component notation of vector. For example, as you can see, we can express the A vector in this form. A is equal to A1 into I cap plus A2 into J cap plus A3 into K cap, and B is equal to B1 into I cap plus B2 into J cap plus B3 into K cap. Okay, here I, J and K are the unit vectors in the direction of X, Y and Z axis. And A1 is the component of A vector in the direction of x-axis, A2 is the component of A vector in the direction of y-axis, and A3 is the component of A vector in the direction of z-axis. Similarly, we can have B1, B2 and B3. Okay, so if we take the cross product between two vectors, just we have to cross this vector with this vector. Okay, as you can see, the first term is I cross I, then second term I cross J, the third term I cross K. Okay, I have already taught you in the last semester that I cross I is equal to 0, I cross J it will give you plus K, and I cross K it will give you minus J. Okay, similarly J cross I will give you minus K, J cross J will give you 0, and J cross K will give you I, plus I, and K cross I will give you plus J, K cross J will give you minus I, k cos k will give you 0. So if you if we sum up all this thing, then we can get the magnitude of the we can get the value of the cross product between these two vector like this: a2 b3 minus a3 b2 into I cap plus a3 b1 minus a1 b3 into j cap plus a1 b2 minus a2 b1 into k cap. Okay, so this can be nicely put in a determinant notation. So the cross product in determinant notation is represented by this symbol, where we just have to do one thing: I, j, k. Then in the first arrow will be a1 a2 a3, and the second arrow will be b1 b2 b3. So if we want to find the x component, so you have to just omit this and say a2 b3 minus b3 b2 a3. This is the I component, as you can see here. Okay, so for j component you have to omit this, then a3 b1 minus a1 b3 into j cap. And for j component, what you have to do, omit this column, and you can see a1 a2 minus b1 a2 into k cap. So using this compact formation, we can express the ordinary we can express the cross product between two vector. Okay, so okay. There is another after the multiplication and after addition and subtraction, there is the obvious question is in mind is whether there will be vector division or not. Okay, so it is to be noted that the vector division is not a well-defined quantity in physics, because if you see suppose a is suppose we say that a vector is divisible by b and its magnitude is c, so we can write a is equal to b cross c. So this is the ordinary definition of the division. But one of the condition that c vector has to satisfy, that c vector must be perpendicular to the vector a. So c vector has to be always perpendicular to the vector a in order to define a divisibility by vector b. So there are some special conditions which each vector has to satisfy in order to have any meaning of division. Therefore, in physics, the vector division is not well defined. Okay. Another problem with vector division is that suppose we have a vector c, a vector divided by b is equal to c vector, and c satisfy a is equal to b cross c. Then any vector, if you write d is equal to c plus beta into b, then this vector also satisfies the similar condition, because if you can see a is equal to b cross d vector, but b cross d is equal to nothing but b cross c. Okay, so there cannot be any unique vector c which specially satisfy this condition, a is equal to b cross c. Therefore, in vector algebra, the vector division is not a well-defined concept. Okay, so we can say that we know what is the vector addition, we know what is the vector subtraction, and we know what is the vector dot product and vector cross product. But we can never say that we can define a vector divisibility by another vector. So the division of vector is never been a well-defined concept in mathematics as well as in physics. So in the third part of the video, I am going to discuss about the vector triple product.